Hello pre-calc students, this is Mr. McAllen, and I'm just going to be going over the review that is for the test tomorrow on piecewise functions, and also there are some questions on parent function transformations, combination of the both using piecewise, and graphing transformations with a given function. So what we're going to do is start off on that. So remember, when you have a piecewise function, in terms of this problem, we have two domains to concentrate on. We have what's going on from 0 to 1 and from 1 to 3. So from 0 to 1, all we have to do is plug 0 and 1 into this equation. So when we put 0 in, we get -4. And when we put 1 in, we get -1. So because if they both have an equal sign, we leave it as a solid dot. And then when we're at 1, we plug in to the other function, but we leave that as a open hole. So when I plug 1 into here, I get -3. So that'll be right there. And then when I plug 3 in, I get 9 minus 6 is 3. So I'm at 3. And this would be the graph for that piecewise function. I'm going to graph the next one to save you time, so you don't have to listen to me, and I'll come back and talk about it after I graph it. So I'm just going to pause the camera while I work on it, and then when I have the results, I'll turn the camera back on. Okay, class, so I'm back, and I've worked through this problem, and you have to be careful and take your time with it because it's 3 pieces. And if you look at it in black, I did the function y equals x, and y equals x is a positively moving function. It's got a positive slope, and when you're at -1, I plotted in plotted negative. Well, I actually plotted in this order. Well, I plotted -3 and I got -3. I plotted -1 and I got -1. So here are the points, and then I drew the curve through it, and I remembered to leave it open because of the inequality symbol. And then when I was on the next graph, I just graphed that in red so you can follow that, and I graphed the third one in blue so you could follow that. And the key here is to put in points that are appropriate for the domain. So hopefully that helps. And on the next problem, we want you to show that you can write equations for the graphs shown below, where we know that this is a square root function that has been flipped over the y-axis, so that would be a negative on the inside in front of x. It's been moved to the right by 2, so we want to do -2, so that when we set the expression inside the radical equal to 0, we get x equals -2, and it's gone up 3, so we're going to say +3. So that would be that function. Over here we have a cubic function that's been flipped, and it's been flipped over either the y or the x-axis, so I'm going to do the solution for both. So if it's a cubic function, and I have the flip over the x-axis, the negative would go on the outside. If it goes to the left by 3, I would say x plus 3, and down 4, so that's one possibility. If you want to graph the other possibility, you could graph it as a flip over the y-axis, and I would have to adjust my expression on the inside of the function the following way to make sure that the graph appeared correct. On the next graph, it says to graph this function, so what we want to do is we want to draw another piecewise, but here you see we have a radical function mixed in, so we're going to use our knowledge of parent functions to draw that on the domain from 0 to 4. So we're kind of combining both sets of problems that we've been doing. So I'm going to just draw a nice graphing grid. So let me do that. And I'll make sure my tick marks are, well, I'm going to pause the camera and get everything set up, and then I'll come back and explain. Okay, so I'm back, and when I start off the first function, I'll just make the first function in black, and I'm going to put in points that are to the left of 0. So my first point is going to be, I'll make a little table here, and I'll put in -1, and then I'll put 0 in. So if I put -1 in the first function, I'm going to get -3. And if I put 0 in the first function, I'm going to get -1. And I've got to keep that open. So that's going to be the first part. The next part is going to be a square root function that's been moved down by 2. So that's going to go on from 0 to 4. So it's been moved down by 2. So I'm going to draw that in red. So that, I'm just going to use my parent function knowledge. So I'm going to go down 2. That's going to be solid. Oh, that's down 3. Hold on, let me erase that. And it's going to go, when I get to 4, I'm going to have the value of, when you plug in, when you plug 0 into this, you get -2. And when you plug in 4 into the second function, you get 2 minus 2, you'll get 0. So when I'm at 1, 2, 3, 4, I'll be at 0, and I'll have the square root type graph. The last one, I'm going to plot in blue. And that's going to be greater than 4, so I'm going to put 4 in, but leave it open. And this one was open, and these two were both closed. So when I put 4 in, I'm going to get 2, and when I put 6 in, I'm going to get 3. So it's going to be a linear function. So when I put 4 in, I'm going to get 2. I'm going to put 6 in, I'm going to get 3. So my function is going to go off in that direction as such, and that's got to be an open circle. So hopefully that helps explain how to do that. And the last one is sketching using this cubic function by looking at these operations. So I'm going to just redraw them because it's going to take a little bit of time to redraw each one the appropriate way. So I'm going to just draw them over here, and then I'll turn the camera back on when I'm done. Okay, well, I'm back. So I want to just explain for each one what we do with this graph. So in each one of these, we're going to have to make a graph on the test tomorrow. And in each plot, as you see with number 1, it says basically when you're looking at this plot, the first thing you want to do is tell me or write on your test what you're going to do with all the points based on this transformation rule. So in the first one, you want to move all points left 1 unit. On the next one, that one's telling you to move all points up 1 unit. The next one, you want to flip the graph over the y-axis. The next one, you want to flip the graph over the x-axis. And the last one, you want to flip first over the y-axis, and then translate right to. So we're going to graph the last one. If we flip all the points over the y-axis, basically this point at 3, 3, 2 becomes the point at -3, 2. The point here at 2, -2 becomes -2, -2. The point here at 0, 2 stays at 0, 2. Because when a point's on the y-axis, it doesn't move at all. And the point here at -1, -2 goes to 1, -2. So the graph would appear like that. Oops. And now we move all the points to the right by 2. So I'm just going to put their coordinates on here. So this is -2, comma, -2. This was 0, 2. And this is 1, comma, -2. So now I just move all those points over. So I'll just draw that next translation in black. So this point at 3, -3, -3, 2 goes to -1, 2. The point at -2, -2 goes to 0, 2, or 0, -2. The next point at 0, 2 goes to 2, 2. And the last point goes to 3, -2. And now we have our final graph. So hopefully this gives you an idea of what we have to do with our translations and further stuff tomorrow on the test. Remember, we also have finding the maximum volume of a box, so be ready to work on that problem as well and look through your notes on that. Hope this helps, and we'll talk to you soon. Goodbye.